Welcome guys. How is there? Thank you for watching us. So today we are looking about mathematics, but first and foremost, my name is Edward, or some people call me Teacher Edward. Teacher Edward is the one who is going to take you through mathematics. First and foremost, we have come doing mathematics from primary, secondary, that's all level. Now we are taking mathematics in A-level. Thank you for keeping that spirit and working hard in mathematics. So, as you know, mathematics in O-level had two papers, that is paper 1 and paper 2. But the different thing with mathematics in O-level is that it was taught as one paper, or as the same mathematics, and then after that mathematics was categorized into two papers. But when you come to A-level, you still learn about the same mathematics. But here the difference is that each paper is taught differently. For example, in A-level our mathematics, we have mathematics paper 1. That's our maths paper 1. Maths paper 1, this one is called pure mathematics. We call it as pure mathematics. And there is another paper which is maths paper 2. Paper 2. This one is called applied mathematics. These are basically two papers of mathematics taught at A-level. We have paper 1 and paper 2. Paper 1 is the one which is called pure mathematics, and then paper 2 is the one which is called applied mathematics. But for our area of interest, or what we are going to look at, we are going to look at what we are calling mathematics paper 2. That is maths paper 2. Maths paper 2 is the one which we are calling applied mathematics. Applied mathematics is one paper, but under applied mathematics we have three different themes. The first theme in applied mathematics is called themes. In applied mathematics we have only three themes, of which the first one is called mechanics. The first one is called mechanics. This is mechanical mathematics. It mainly deals with computations of mechanical things. The way you can hear mechanical engineering, mechanical or other electronic things, but mainly here we focus on mechanical part of mathematics. That's computation dealing with forces, accelerations, and others which shall look at as we go on. Then the second theme is called statistics and probability. That is statistics and probability. Finally, the last theme under Maths 2 we have numerical methods. Numerical methods. Those are few themes, or those are the three themes which we are going to look at in mathematics or in mathematics paper 2. So, first and foremost, in applied mechanics or in applied mathematics, we are going to look at what we call mechanics. That's our first theme, which we shall look at today. It's called mechanics. But mechanics is having different topics, which shall be looking one at a time. So those topics, we shall look them one at a time and in details, and then we do the numerical part of them. That is stating what they mean and then doing problems concerning those topics. So we are going to start with what we call applied mathematics, and then the theme which we are looking at applied mathematics, we are looking at applied mathematics. Then the theme we shall look at today, the theme is the one which we are calling mechanics. We are going to look at mechanics. So under mechanics, we shall start with a topic called components and the resultant forces. Components and the resultant forces. So this is what our topic for today. We are going to cover from a theme called mechanics or mechanics mathematics. The topic which we are going to look at is called components and resultant forces or resultant of forces. We can even add the word of forces. We can say resultant of forces. So, before we proceed in this topic, the way you are hearing it, that is called components and resultant of forces. What you need to understand most or first, what is force? What is a force? The first question you need to ask yourself is, what is a force? That's the first question you need to ask yourself, that what is a force? So, we all know that from our O level we define force as, we say the force is a push or pull of an object or of a body. You can call push or pull of an object or a body, of an object or a body. That is, if I have this marker, the energy I'm using to push this marker through this distance is what we are calling a force. Now, take for example, you have this particle or you have this object P or object Q. You are pulling it in that direction to the right of your hand. This pulling which you are pulling this object, implying this object will come from this distance. Now, after pulling it, it will be up to this distance. And then the energy you have used to move this object from this distance to this one is called force. Then here we put it as capital F. Force, we know force is a vector quantity. What does it mean? That whenever you are dealing with a force, you should have both magnitude and direction. So take note that force is a vector quantity. Force is a vector quantity. So it has both magnitude you can say both magnitude, both size, and it can say both magnitude or size and direction So this one means that once you get a question saying calculate force acting on the body, you should get the amount of force which is required, or the amount of force which is required, and then after you state the direction where the force is acting. So this one is slightly different from what we covered in O level. In O level we said if they would tell you calculate force, we could just calculate force and then we stop there. Now for example, in O level, if they told you that calculate the force, maybe let us say that there is a force P and Q acting on the particle or on the body. Let us say force, take note, this is our example, that a force of 2 newtons and 3 newtons acts on the body as shown below. As shown. So this is the body and then this is the force. This is 3 Newton and then this one is taking it in the same direction as 2 Newton. So they will tell you calculate the force or the resultant force acting on the body. Calculate the resultant force acting on the body. Calculate the resultant force acting on the body. So this one means we are going to get the total force which is acting on the body. Someone is pulling this marker with 3 and then another one is also pulling it with 2 in the same direction. So the resultant force, we say, the resultant force we get this one plus 3 plus 2. The resultant force, which is denoted as capital F, is given by 3 plus 2, which equals to 5 Newton. But this one is on the magnitude. This is the size of the force which is acting on that body. But we said the force is a vector quantity. It should have both size and direction. Now here you specify in which direction is the force going. Now when you see me, this one is my right hand side and then this one is my left hand side. So the resultant force on this body is going in that direction. So if this one is pulling it that side and also this one is pulling it that side, implying the force is going in that direction. Which direction is this one? We say in the right hand side. That's what we say. That force acting on this body is 5 Newton. In which direction? The direction is the one which we are calling in the right hand side. That's the force. So that's what makes it different from what we covered in other book. But the calculation almost remains the same, only that here we add one component of right hand side. So after understanding what force means and how we are supposed to state our force, there are 2 types of forces which act on the body. There are 2 types of forces which act on the body. Types of forces which act on the body. Which acts on the body. The first type of force, we have said, it is called coplanar force. Coplanar force. This one is A. It is called coplanar force. The first type of force we are having is called coplanar force or coplanar forces. Coplanar force or coplanar forces. These are type of force which when they act on the body, the line of action lie on the same plane. Type of force which when acts on the body, the line of action lie in the same plane. The line of action lie in the same plane. Coplanar forces, these are forces whose line of action, these are forces whose line of action, lie in the same plane. Line of action lie in the same plane. Whose line of action lie in the same plane. Those are what we are calling coplanar forces. The line of action is lying in the same plane, but at different points. This force, they can act at different points, but when they are in the same plane, or when they are on the same plane. So, the next type of force we have is called concurrent forces. Concurrent forces, these are forces which act at the same point. Concurrent forces, we say, these are forces which act at the same point. These are type of forces which act at the same points. Those are what we are calling concurrent forces. Concurrent forces. They are both concurrent forces. But the SP, this one is called concurrent forces. Concurrent forces. Concurrent forces. So these are two types of forces which we have. That if you have the body, this force going this side, let us say it is force P, and this one is force Q. You see that all of them are acting at the same point, but in different directions. So yeah, the direction doesn't matter, but what matters is at which point are those forces acting. So they are acting concurrently, both of them act at the same time and at the same point. So those are mainly what we shall be looking at. So let us go to the next thing which we have. Let's see. So in brief, that's what was about force. So let us go to our sub-heading of today, that the topics was components and resultant of forces. So what do we need now? We have looked at forces, what they are. We have looked at types of forces, which you now know. We have looked how we calculate a force, that it must contain a direction. So what we are going to look at now is resultant of forces, or calculating the resultant forces. Resultant of forces. Resultant of forces. So we are going to look at resultant of forces. Now we have seen the same, we have seen the components, we have seen now we are going to see the resultant of forces. That the first thing which we have, suppose if forces P and Q are concurrent. If forces P and Q acts on the body concurrently. Act on the body concurrently. Full stop. If force P and Q acts on the body concurrent, as shown, as we are seeing it below this text, as shown. If forces P and Q acts on the body as shown. The first part, you are seeing it as shown as this one. This one is pulling this side. This is our point of the body, so the force which is pulling is that. We said concurrent forces act at the same point and then act in the same direction. I mean, they act at the same point, but they can act in different directions. That's force Q. So, the question is saying, calculate resultant calculate the resultant force R. Now for this case, the resultant force we are calling it R. So the resultant force, if this one is pulling you with P, and this one is pulling you with Q, that if P is greater than Q, implying you move in that direction of bigger force. But if Q is greater than P, then you move in direction of Q. But if P is greater than Q, then you move in the direction of Q. So here we shall say if P is greater than Q, our resultant force R is given by, resultant force R will be given by P minus Q. Since P is bigger than Q, where will the direction be? We shall move to the right hand side. To the right hand side, that's the direction of force. Because if this one is pulling with bigger amount of force, this body will move that side. So that one means that the body or the resultant force will act, but when the body is moving in our right hand side. If yours is Q is greater than P, then yours will move in the left hand side. So that's the difference now between the forces which are going to calculate. So that's our first part of the resultant force. And then there is another part that if these two forces are acting in the same direction, Roman 2 we have Roman 2, this is our Roman 2, that if this body is being acted upon by two forces, P and Q, and if they are in the same direction, P and Q, in the same direction, the question is still the same, that calculate the resultant force. Question is still the same, that calculate the resultant force. So for the forces in the same direction, if this one is pulling you with 2 and then the other one is pulling you with 1, the resultant force increases in that direction where those two people are pulling you. So our resultant force here is calculated by, resultant force R is given by P plus Q. In which direction? We are still moving in the same direction, to the left. The direction, the resultant will be moving to the right hand side. To the right hand side. That's the direction of force. Then the next thing, if now we have more than two forces acting on the body, more than two, that's 3, 4, or 5. How do we calculate those forces? Then let us look at how we calculate the resultant forces. If forces, let us say if forces if forces P, Q, and S, P, Q, and S are concurrent, and acts on the body as shown. So, if forces P, Q, and S acts on the body as shown, which one? That this is our body, and then the forces P is acting in this direction, forces Q is in the same direction, then forces S is in this direction. How do we get the resultant forces there? How do we get the resultant force? The resultant force, now here, the resultant force, so let us say calculate. The resultant force R. Calculate the resultant force R. Now, this is our first drawing, and we have said the forces P, Q, and S are concurrent. That means that all of them are acting at the same time. Then, if they are acting at the same time, they are acting on the body as shown. Implying the direction of these forces, they are as shown. So, we say if forces are moving in the same direction, we get the resultant by adding from the previous example. Then, if they are in a different direction, we get the forces by subtracting which one is big and which one is small. Then we put the directions. Now, for this case, the first step, we shall need to get the total forces which are going to the right hand side. So, here the total forces are total forces acting on the body to the right. The total forces acting on the body to the right is given by, which are those forces acting to the right? We have P and Q. So the total forces is given by P plus Q. Then what is our new setup of the body? Right now on our body, we have two forces acting. We have this force, which is P plus Q. Then there is this force, which is S. Now, since P and Q is likely to be greater than S, then where will the direction of our body be? So these two people will pull S. If you are being pulled by 3 people, 2 people are taking you to the right and 1 person is taking you to the left. Where are you likely to go? You are likely to go to the direction where those 2 people are pulling you. So the resultant force R, the resultant force R is given by R equals to P plus Q into bracket minus S. That's how we calculate that resultant force. And then you put the direction where the force is going. This one, they are still moving to the left hand. They are moving to the right hand. right hand side. So forces are moving, or the body, the resultant force on the body is moving to the right hand side, which we have got by first adding the forces which are in the same direction, that is P plus Q, and then after we subtract the force which is opposing them, which is S. So P plus Q minus S give us our resultant force on S. That's when you have two forces. But there are some cases when you have three forces and when you have four forces, you repeat the same procedures. First, result of forces in the same direction. Then, after resolving forces in the same direction, get the forces in different direction, and then subtract them. So that's mainly what we are going to, how we are going to be getting the resultant force. Now, that is the resultant force on a straight line. But we have a resultant force when a force is acting at a given angle. Calculating resultant force says acting at a given angle. So, after understanding the resultant forces in different directions, we say let force P, maybe let force F, and let force F act, let force F act at an angle theta to the horizontal. To the horizontal, as shown. Act to the horizontal as shown. This is our force. It's acting, going upward. The force is acting, going upward, but they have given us this angle to the horizontal as theta. This is our star, the angle which it is acting upon, and this is our force F. Then, this force is not the same force as we have been looking at. This one is acting at a given angle. So, here it leads us to components of forces. This force acting at this angle has both horizontal and vertical components. From your trigonometry in O level, you can get the horizontal components and then the vertical component. Let us look at what you covered in O level in trigonometry. We said if this one is an angle, which is a right hand angle, and then it is on a star, this one is our side, maybe this one is 1, 1, and then this one become 4. Since the angle is here, you say this one is opposite. The angle which is opposite to that, the side which is opposite to that angle is called opposite. And then which is after the opposite, the one which is next to that angle is called adjacent. And then this one is called hypotenuse. So, from this one, we say that our angle is given by, if you want to get the sine star of angle is given by opposite out of hypotenuse, and then cos theta is given by adjacent out of hypotenuse, and then the other angle which we learned about was tan star which is given by opposite over adjacent. So that's how we say we can calculate this one. So if you know these identities, the sine, the cosine, and the tan angles, how you get them. Now this force is having those one which we are calling vertical components and horizontal component. Where is the vertical component of force? If this force is going upward, which are follow vector direction, that you first move from this point up to this one, which is the force which you call the horizontal component of the force, and then you move upward, which is called the vertical components of the force. And then this is the resultant force F. Now this one becomes resultant force F. So how do we get the resultant force? Let this one be the resultant force R acting in that direction. Let us change it to R acting in that direction. So how do we calculate this resultant force? First and foremost, we need to know how to get the components of horizontal force and then component of vertical force. Component of horizontal force. Now we have our angle, but we don't have the value of H, and we don't have the value of adjacent, and the value of opposite, and then the value of hypotenuse. So from this one, we know that our sine star is given by opposite out of hypotenuse. So what is our opposite? Our opposite in this case, we have it as Fx. Our opposite, we have it as Fx. Opposite equals to, implying our sine star equals to opposite, which is Fv. Or you can call it Fy because it is going to the y direction. Let us call it Fy. Out of hypotenuse. Hypotenuse is the original force which we add. The original force before calculating this resultant we had, it was force F. So this force F is the one which is on hypotenuse. This is the one which is taking the longest side. It is here, and then we are getting its components of opposite and adjacent. This is the original force which we add. So now our opposite become F. Remember, we want to get what? The vertical component of F. Since this one is unknown, but this one we know it, and then we know the angle. This one is out of 1, we cross, multiply. This one come this side, and then this one come this side. So we have our force F of y is given as F times sine star will remain is F sine theta. This is what we are calling the vertical component of force F. This is what we are calling the vertical component of force F. This is the vertical component. This is the vertical component of force F. So whenever we are calculating the vertical component of any force, we shall use that force and then we multiply it by the sine angle or the sine of that angle which is given. That's how we shall be we shall be calculating our vertical component. Then from cos given as, cos star equals to, what is our cos star equals to? From cos star equals to adjacent up out of hypotenuse. So our cos star equals to, what is our adjacent? Adjacent, this is the angle which is next to this is the line which is next to the angle, but not the longest. So this one we say is our f. Now let us make it our fx. Our fx, for his understanding, implying that it's along horizontal or x-axis. So our adjacent is first fx, which is along the x-axis out of hypotenuse. Hypotenuse is the longest side. The longest side was having force F. Out of force F. Then what do we need to get? We need to get our force F of x. So our force F of x, our force F of x, our force F of x become F. This one is out of 1. We could also multiply F cos of theta. So this is how we shall calculate the horizontal component of force. So next time we are going to we shall start from this one and then we proceed to example. See you next time.